This is our e-learning lesson for Monday, March 8th. We are going to begin looking at the fundamental counting principle and how it applies to counting the number of ways we can have an event occur. And I'll explain what that means here below. But many real-life problems involve counting the number of possible outcomes. For example, counting the number of possible ice cream sundaes that could be made given the choice of one flavor of ice cream, one sauce, and one topping. Normally, I do a tree diagram on the board. We'll maybe look at that in class on Tuesday or Wednesday, but let's say we had 3 different flavors of ice cream and 2 different sauces and 3 different toppings. You could list out all the different combinations of sundaes taking one flavor of ice cream, one sauce, and one topping. And of course, that could be very lengthy if you listed those choices all out. However, the fundamental counting principle allows us to count those without necessarily having to list them all out. And you can see here below it says if one event occurs in m ways and another event occurs in n ways, then the number of ways both events can occur is m times n. And of course, this principle applies to 3 or more events. An event is like choosing a flavor of ice cream, choosing a sauce, and choosing a topping. And so in my example, if I had 3 flavors of ice cream and 2 sauces and 3 toppings, that would end up being 3 times 2 times 3, or 18 unique sundaes that include one flavor of ice cream, one sauce, and one topping. And using the fundamental counting principle definitely beats having to list and count out all the possible combinations. So that is the fundamental counting principle. And we're going to use it on a worksheet below. But first I want to talk about independent events and dependent events, because the fundamental counting principle applies to both, but it affects how we know how many outcomes we're dealing with. So an independent event is when the outcome of one event does not affect the outcome of another event and vice versa. But dependent events, the outcome of an event does affect the outcome of another event. That means they're dependent. And you're going to see, as I said, how this works out with some problems below. Then factorials. A factorial in mathematics is a special product that I will show you how to find using your calculator in class. But it is the product of all positive integers starting at n down to 1. And we write n factorial, which it's written as n exclamation point, but that really is read n factorial by writing out the product of the positive integers from n down to 1. For instance, 5 factorial, written like that, is really the product 5 times 4 times 3 times 2 times 1. And sure, you could take your calculator and enter 5 times 4 times 3 times 2 times 1, but that would take a long time if you did like 10 factorial. And there is a shortcut that you can use with your calculator that I will show you in class. But this would be 20 times 6, or 120. When the factorial is small, it's not so difficult to find it. 0 factorial is always going to be 1. I will show you in class again on Tuesday or Wednesday why that is the case. And your calculator can remind you of it, but a lot of people like to think 0 factorial is 0, but that's simply not the case. All right, so let's see how this works. This first side of my worksheet deals with independent events. And if you look at the top at the example, they give an example of a breakfast special at the Country Pantry where customers can choose their eggs scrambled, fried, or poached. So there's 3 ways to choose the eggs. whole wheat or white toast, 2 ways to choose toast, and either orange, apple, tomato, or grapefruit juice, which that means there's 4 choices for juice. So the number of different breakfast specials, assuming you're ordering one of each, would be the product of 3 times 2 times 4, or 24 ways to choose the breakfast special. So let's take a look at some of these examples below. The Palace of Pizza offers small, medium, or large pizzas with 14 different toppings available. So that would mean there's 3 different sizes and 14 different toppings, and we're just having one of each, and then we'd multiply, and that would give us 42. I do want to see how you arrive at your answer, not just the answer of 42. Number 2, the letters A, B, C, and D are used to form 4-letter passwords for entering a computer file. How many passwords are possible if letters can be repeated? So that means there's 4 choices for each of the 4 letters. So that would be 4 times 4 times 4, which you could write as 4 raised to the 4th, and that's going to be 256. How about 3? A restaurant serves 5 main dishes, 3 salads, and 4 desserts. How many different meals could be ordered if each has a main dish, a salad, and a dessert? And of course, that would be 5 times 3 times 4, and that's going to be 60. Marissa brought 8 t-shirts and 6 pairs of shorts to summer camp. How many different outfits consisting of a t-shirt and a pair of shorts does she have? Well, assuming they don't care if they match or not, you would take 8 times 6, and that would be 48 unique outfits. Number 5, there are 6 different packages available for school pictures. The studio offers 5 different backgrounds and 2 different finishes. How many different options are available? So 6 times 5 times 2. And all of these are independent events. What you choose for one event does not affect the choice for another event. You're just counting. Number 5 or 6 is a little more interesting. It says how many 5-digit even numbers can be formed using the digits 4, 6, 7, 2, and 8 if digits can be repeated. I like to use blank lines to kind of represent the 5 digits. And it says how many 5-digit even numbers. What that means is the last digit has to be even. And if I look at my choices, all but 1 are even digits. So 4, 6, 2, and 8, I cannot use the 7 because it's not even. And so in the last position, there are 4 choices. But since digits can be repeated, all the others, there are 5 possibilities for their positions. So this is really 5 to the 4th times 4. And if you take your calculator, you're going to figure out that's 2,500. How about number 7? This is the classic standardized test question. How many license plate numbers consisting of 3 letters followed by 3 numbers are possible when repetition is allowed? So how many letters are in the alphabet? Hopefully you know that's 26. Assuming we only are using capital letters, that would mean if we're allowed to repeat for the letters, 26 times 26 times 26, and then for the numbers, they're actually meaning digits. A lot of students will say 9 here, but you have to remember 0 is a digit, so there's actually 10 digits, 0 to 9. And so this is 26 to the 3rd times 10 to the 3rd, which is 17,576,000. That's a lot. Oops. There you go. Number 8, how many 4-digit positive even integers are there? This one's tricky. 4 spaces because we want 4 digits. Assuming we have 4 digits and the leading digit can't be 0, there would be 9 possibilities in the first position. In the last position, to be even, that would be 0, 2, 4, 6, and 8. So that means 5 possibilities in the last. And then the other 2 positions, there could be 10. So 9 times 10 times 10 times 5, that would be 100 times 45, or 4,500. These are independent events where the outcomes don't affect the other events. Now, looking at the flip side of this worksheet are where we have dependent events. And I think the example up at the top is a great one. It says, the guests at a sleepover brought 8 videos. They decided they would only watch 3 videos. How many orders of 3 different videos are possible? Now, assuming you have your friends over, non-COVID, for a sleepover, and you're going to watch videos, then I don't think you're probably going to watch the same video 3 consecutive times. So this is where the events would be considered dependent, because your first choice is going to affect your second and your third choice. So for the first video, if you have 8 videos to choose from, there are 8 possibilities. Then there's 1 less for the second video you watch, 7. And then the third time, there are only 6 videos. And so you'd be taking 8 times 7 times 6, or 336 orders of 3 different videos. So this is dependent events with the fundamental counting principle. So the first problem we see is 3 students are scheduled to give oral reports on Monday. In how many ways can their presentations be ordered? Well, if you have 3 students, for the first report, there are 3 students available to give the report. Then once the first student gives the report, there's only 2 available for the second position, and then that leaves only 1 in the last position. That's going to be 3 times 2 times 1, or 6. I want to point out here that this is equivalent to saying 3 factorial, because that would be the product starting at 3 and going down to 1, and we'll look at how we can do that on your calculator as well. Number 2. In how many ways can the first 5 letters of the alphabet be arranged if each letter is used only once? So there'd be 5 blank lines. For the first position, there are 5 letters available. And if you can only use each letter once, for the second position, that leaves 4 available. Then for the third, 3, then 2, then 1. And that is equivalent to saying 5 factorial, or 120. Remember, that's like 5 exclamation point. Number 3, in how many different ways can 4 different books be arranged on the shelf? So 4 books on the shelf. For the first position, there's 4. And since they're different books, then that makes 3 for the next position, then 2, then 1. Again, that's 4 factorial, which would be 24. Here's our classic license plate problem again, but it's different. It says how many license plates consisting of 3 letters, followed by 3 numbers, just like before, are possible when no repetition is allowed. So for the letters, the first position we have 26, but if you can't repeat, that means 25, then 24. And for the numbers, you have 10 for the first, then 9, then 8. And if you get that product, that's not quite as large. That's 11,232,000. Number 5, 16 teams are competing in a soccer match. Gold, silver, and bronze will be awarded to the top 3 finishers. In how many ways can the medals be awarded? Well, there are 16 teams, and so there are 16 teams that could get the gold. Once the gold's been awarded, there are only 15 teams for the silver, and for the bronze, there would be 14 teams. 16 times 15 times 14 is 3,360. How about 6? In a word building game, each player picks 7 letter tiles. If Julio's letters are all different, how many 3-letter combinations can he make out of 7 letters? So he has 7 letters, but he's trying to make 3-letter combinations, and they're all different. So there's 7 for the first slot, 6 for the second, and 5 for the third. 30 times 7 would be 210. 7. The editor has accepted 6 articles for the newsletter. In how many ways can the 6 articles be ordered? Since there are 6 different articles, that would have to be 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, or 720. Number 8. There are 10 one-hour workshops scheduled for the open house at the greenhouse. There's only 1 conference room available. In how many ways can the workshops be ordered? Just like the last one, that can be written as 10 factorial. I'm not going to write that out as a product from 10 down to 1, but that is 3,628,800. And again, I'll show you how to do that on your calculator. Finally, the last one. The top 5 runners at the cross-country meet will receive trophies. If there are 22 runners in the race, how many ways can the trophies be awarded? So 5 places, 22 could be up for the first position, then 21, 20, 19, and 18. If you multiply that all out, that'd be 3,160,080. And we'll learn more about this as we extend upon this on Tuesday or Wednesday in class. But that is the fundamental counting principle. Your assignment should be pretty easy. You are doing page P11. It is a page in the old textbook, and it should be found on Canvas. You can see that there and do all the problems. There aren't that many. Please show how you arrive at your answer, what numbers you're multiplying together, and we will go over this in class. Hope you have a great day. We will see you Tuesday or Wednesday. Thanks.